Hi everybody, the purpose of this video is to go over your homework assignment for section 4.2 addition rules for probability. So here is our notorious Hawks lesson screen. Of course we know what these three parts are. Let's just top into Certifier really quickly. Notice that you have 12 problems, each have exactly one step. You have 3 lives. You need to get 9 of the 12 correct before the due date in order to get 100 on your homework. As usual, I'm going to do this in practice. Okay, so let me go ahead and start. Okay, once again, practice is the exact same type of problem. They just give you more feedback. And now we need to determine whether the following value could be a probability. The answer is no, it cannot be a probability. Why? This number is greater than 1. If you're not sure that number is greater than 1, here's what you can do. You can go to your calculator, do 33 divided by 17. And you get 1.9. That number is greater than 1. This cannot be a probability. Okay, determine that the following clubs or events are mutually exclusive. A jack or a club out of a deck of cards. Now remember, for something to be mutually exclusive, they cannot have any common elements. If you're not too sure what a standard deck of cards looks like, click right here. Here is your standard deck of cards. Okay, these are all the clubs. Okay, this is a jack. Okay, notice that that the set of all jacks and the set of clubs have a common member, namely that one. These are not mutually exclusive. Okay, how about this one? Choosing a diamond or a black card out of a standard deck of cards. Well, let's look at our deck of cards again. These are the diamonds. Notice that they are all red. These are all the black cards. Black cards are only either spades or clubs. Okay, there's no way a diamond can be a black card. They share no common elements. This is mutually exclusive. Okay. Now this is the problem. Now this is the type of problem. It's not clear, which is why we're going through this, where the probability of any two events on here, or the probability of the intersection of any two events, is going to be equal to 0. In other words, every single one of these events are mutually exclusive. There is no one taking a bar class and a boot camp at the exact same time, or so forth. Okay. So look what we have here. So we have here a group fitness gym classifies as fitness by class, by attendees, and by class type and member status. The marketing team has gathered data from a random month in which there were 2,101 class attendees. That's basically telling you that the size of the sample space is equal to 2,101. What is the probability of a class attendee being a member of the gym and attending boot camp? So we want to know the probability of a class attendee being a member and attending boot camp, or a non-member attending yoga class. Well, using our addition rule for probability, this is going to be equal to the probability of a member attending bar class plus the probability of a non-member attending yoga class minus the probability of their intersection. Based upon this will be equal to 0. So this is going to be equal to the probability of a member attending bar class plus a non-member attending yoga class. Looks like I'm writing out New York. Okay, so the probability of a member taking bar class is going to be equal to the number of members that are taking the bar class, that is 235, divided by 2101, plus, and now the probability of a non-member taking yoga class, well, that's right here, 277, divided by 2101, and that is going to be equal to 512 divided by 2101. Now we need to see if this fraction is reduced, and we can do that. And we can do that as follows. Just type in your calculator. Turn back to my calculator now. 512 divided by 2101 is equal to that. Now to see if this is a reduced fraction, or what the reduced fraction is, just go to Math, and then hit enter twice. Enter, enter. And notice we have the exact same value. So this is our reduced fraction. So that is how we can answer this. One of two ways. One is as a reduced fraction, or the other way would be to enter in 0.2437. Notice here that my fifth decimal place is 5 or higher, so I would need to round that up to a 7. Now for this one, I want to go ahead and put it in the fraction. The way I can do that is hit slash. And notice that this is a different format. You actually had it, and it varies. And one of the irritating things about Hawks is they do fractions in two different ways, and I'm never too sure, and it varies from section to section. For this one, you need to do the slash first. Then you can just go 512, and now you just downspace 2101. And I did something wrong. What was my mistake? Well, when you get something like this, what you can do is you can go ahead and hit explain error. And it will go through all that you've done. It tells us what my answer is. It appears I made an error in the following area. Find the probability that a Class NT member is attending boot camp. I did bar class by mistake. That was my mistake. Okay, so I was able to go through here and figure out where my mistake was. So this should not be 235. This should be 206. So we can change this to 206. We can redo the math. 206 plus 277, 303. This should be 303. Divided by 2101 is that value. Just hit math, hit enter twice to see if it's reduced. It is. So that should be our answer, or it could be 0.1442. Since my fifth decimal place is a 1, I don't need to round up. So let's see if that works. Let me go back to practice. Change this to 303. Wait a second. That can't be 303. Oh, I forgot the 0 there, so I need to do this all over again. So 206 plus 277 is 483 divided by 2101, and that should give us 0.2299. So let's see if that's right. 483. And it is. And that's actually one of the advantages of going through practice. If you make a mistake, you can it can walk you through and tell you what your mistake was. Where in my case it was kind of trivial, but if there's a fundamental misunderstanding, they can actually help you there. Whereas if you're in Certify, they'll just tell you that you're wrong, and then if you want to continue or not. So if you get stuck in Certify, that's always good to come back to practice. Okay, moving on. Question 5. Determine which value cannot be a probability. Okay, now this is 0. 0 is an acceptable probability. 5, 6, that's a number less than 1. 15% is actually 0.15, so 15% as a decimal is 0.15. That's acceptable. 1.55 is not. That's a number greater than 1. That can never, ever be a probability. Okay, now these are kind of the weird outcome or weird complement problems that we have to deal with in this section. Now we want to find the number of outcomes in the complement of a given book. And it says out of the 318 books that we have, that is the size of your sample space, 139 are mysteries. So the complement of that are going to be all the books that are not, all the other books that are not mysteries. So the complement, the size of the complement, is going to be equal to 318 minus 139. That's all they're looking for. And that should give us 179. Okay. Determine whether the events are mutually exclusive. Choosing a student who is a mathematics major or a psychology major from a nearby university to participate in a research study. And what we are going to assume here is that there are no double majors. You can only choose one major and one major only. Okay, so if you're a mathematics major, you cannot be a philosophy major. Therefore, there are no mathematics majors that are philosophy majors that are mathematics majors. They share no common element. They are mutually exclusive. Okay, determine the complement of this event. 76 prescribers to fitness magazines are over the age of 36, or all old farts like me. Okay, well, if that's the case, then the size of the complement is going to be the total amount, which would be 100%, minus 76%, which should be 24%. That's what goes in here. Okay, moving right along. Determine whether the following events are mutually exclusive. A student who is a junior in college or a mathematics major from a nearby university. Well, you can be a math major and you can be a junior in college. Except at Limestone right now, there are a number of juniors that happen to be math majors. So juniors and the set of all juniors and the set of all math majors have common elements. They are not mutually exclusive. And this brings us to this problem, which hopefully I will do better this time. A group fitness gym classifies its fitness attendees by class type and member status. The marketing team has gathered data from a random month in which 2,183 class attendees. So here, T is 2183. And the question is, find the probability that an attendee does not attend a bar class. So we want to find the probability that the attendee does not attend a bar class. That would be the probability of the complement of the attendees attending the bar class. Now, once again, we could find the probability of all the attendees attending boot camp, all the attendees in boxing class, spinning and yoga, and add them all up. Or we can just find the probability of all the attendees attending bar class and use the complement rule, which is the probability of its complement is equal to 1 minus the probability of the set in question. How many people were attending bar class? What's the probability of somebody attending bar class? Well, that is going to be equal to the probability that a member is attending bar class plus the probability that a non-member is attending bar class minus the probability that of their intersection. But however, since that should be M, not. However, since somebody cannot both be members and non-members, this is equal to 0. So that means that we're going to have that the probability of an attendee attending bar class is going to be the probability of its members attending bar class, which is going to be the number of members, which is 289, divided by the sample space, size of the sample space, 2183, plus non-members attending bar class. So we had 190 attend bar class, divided by 2183. And that will give us 289 plus 190, 479 divided by 2183. And if that's the case, then the probability that attendees did not attend bar class, i.e. its complement, is going to be 1 minus 479 divided by 2183, 83. The better way to write that would be 2183 divided by 2183, that happens to be 1, and we have a common denominator, minus 479 over 2183, and that is going to be equal to 2183 minus 479. 1704 over 2183. Let's see what that, if that's a reduced fraction divided by 2183. It probably is. Yeah, okay. Or as a decimal, this will be equal to 0.7806. Notice that we have a 7 in the fifth place, so that's going to round up. Let's see if I actually get it right this time. 0.7806. There we go. I did mess up this time. Okay, so we have two left. Determine whether this value could be a probability. Well, it's 0 or greater, right? It's less than 1. This is definitely a probability. And that brings us to our last one, which is the dreaded ball question. So we have a box that contains 14 large marbles and 11 small marbles. 6 of the large marbles happen to be green. Well, if 6 of the large marbles happen to be green, then the other 8 have to be white. That way we get 14 large marbles. And it turns out that 4 of the small marbles are white. Well, 4 of the small marbles are white, then that means the other 7 have to be green. If a marble is randomly selected from a box, what is the probability of it being small or green? So we want to find the probability of the marble being small or the marble being green. That is going to be equal to the probability of the marble being small plus the probability of the marble being green minus the probability of the marble being small and green. The probability, now notice here that we have a total of 25 marbles. Okay, so the probability of a marble being small is going to be equal to the number of small marbles you have, which is 11, divided by the total marbles you have, which is 25. The probability of a marble being green is going to be equal to the number of green marbles you have, which is going to be 6 plus 7, divided by the total number of marbles, which is 25. That will be 13 over 25. And then finally, the probability of a marble being small and green, well, there's only 7 of those. 7 over 25. So the probability of a marble being small or green is going to be equal to the probability of a marble being small, 11 over 25, plus the probability of a marble being green, 13 over 25, minus the probability of the marble being small and green, 7 over 25. That will give us 24 over 25. I think it's going to be 17 over 25. Let's see. 11 plus 13 minus 7. 17 over 25. And I'm pretty sure that is going to be a reduced fraction because 17 is a prime number. And 25 is a non-factor of 17. Right. So our answer is either going to be 17/25 or 0.68. I'm going to use the fraction part again just to get used to the notation. So slash, now this one has a different notation. Put in 17, tab, no space, tab, 25. And there you go. And that is how you do your homework for this particular lesson. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.